Welcome everybody to 4.1 Solving Inequalities, hosted by Iridium Tutoring. So what is an inequality? An inequality is a way to compare two values either by showing if one value is greater than, less than, or equal to another value. There are four symbols that denote inequalities as shown in the following. This symbol represents less than, or 3 is less than 4. This symbol represents less than or equals to. So for example, 5 is less than or equals to 10. But this also works for 5 is less than or equals to 5 because 5 equals to 5. This symbol represents greater than. For example, 5 is greater than 3. This symbol represents greater than or equal to. So for example, 10 is greater than or equal to 2, but also works for 10 is greater than or equal to 10, because 10 equals to 10. Compound inequalities. Compound inequalities combine two simple inequalities to form one simple inequality. There are two different types of compound inequalities, and they can be separated by using and or. So for example, we have x is less than or equals to minus 3, and x is greater than 6. And then for the second example, we have x is less than minus 3, or x is greater than 6. The difference between and or is a big difference. And represents the intersection, basically what the x's crossover values are. And in the second example, when it is when or is used, it represents the union. And the union represents all x's in this range. Solution set and interval notation. The solution set to an inequality is the set of values that the number can be. So for example, we have x is greater than 1. In this example, x can be equal to 3, 100, or 1.00001. In other words, there is an infinite number of solutions. It can be anything that's x can be greater than, x can be anything greater than 1. So it can be a billion, a trillion, but it cannot be something less than 1 or equal to 1. So it can't be 1, it can't be 0, it can't be negative 7. We will write the solution set in interval notation using parentheses and brackets. So this is really important in interval notation. Parentheses represents non-inclusive bounds, meaning that the starting and ending number will not be in the solution set. So, going back to this example, since x cannot be greater or equal to 1, x cannot be equal to 1. So therefore, the starting number will not be in the solution set. 1 will not be in the solution set, and it is the starting number. And then we have brackets, which represent inclusive bounds, meaning that the starting / ending number will be in the solution set, or aka inclusive. So if this example were to be x is greater than or equal to 1, that or equals to means that x can equal to 1. And since 1 is the starting number, we will use brackets for on the left of x. Solution set and interval notation continued. Find the solution set in interval notation of 6 is less than x, which is also less or equal to 13. Since x can range from 6 to 13, but not including 6, as you can see right here, there's no or equals to, but including the 13, because there is an or equals to, the solution set in interval notation is 6, 13 with the appropriate notation. So as you can see here, the parentheses is to represent the starting number that is not included, as you can see, not including 6, but the bracket next to 13 means that the ending number, which was 13, is included, right? So in a number line, that would be an open dot on the 6 and a closed dot on the 13. Example 2. Find the solution set in interval notation of x is less than or equals to 3. We will need to count all values less than or equal to 3. So we will denote the right bound as negative infinity. Thus, the solution set is, we have negative infinity to, or negative infinity comma 3 with the appropriate notation. So whenever you are denoting infinity or negative infinity, you usually set that bound as a parentheses for it. And then once again right here, because x is less than or equals to 3, which would mean that it includes 3, so you put a bracket next to it, and with inclusive, you want to put a dot at 3, a closed dot at 3. So as what I just said, intervals dealing with infinity will need to use infinity and negative infinity to show that the intervals will be unbounded in one of the directions. So we have a positive side, which is infinity, as goes to infinity, and negative side, which is negative infinity. When one side of the interval includes infinity or negative infinity, we will use parentheses on that side. So if it's going to be negative infinity, then it's going to be on the left side. So therefore, you will use the left parenthesis. But if it goes to infinity, then you want to put the parentheses on the right side. And that is all for chapter 4.1. And I'll see you guys next time.